To be here today to talk with you about the Z Digital Integration Hub and how that can help and provide advantage for clients that are undertaking digital transformation in their enterprises. We know that clients across many industries are responding to both business pressures and opportunities with digital transformation initiatives. These efforts can certainly provide a significant advantage to an organization in terms of increased ability to meet competition from non-traditional entities, reduced operations risk, etc. In this particular example is banking focused, but clients in other industries like insurance are also seeing shifts in their business, movement from product to client-centric focus, a drive to create new products more quickly, and the growth of package systems like claim systems. Now, although digital transformation can yield significant positive results, the initiatives can really be very broad, and in some cases, the types of transformation required need to be underpinned by changes in how new business functions integrate efficiently and effectively with core systems of record that run mission-critical operations. In many cases, these systems of record for our enterprise clients run on IBM Z, also known as the mainframe environment. For example, in retail banking core systems like demand deposits, ACH, credit and debit card processing typically run on the mainframe, as well as insurance core systems like claims adjudication, member processing, etc. Now, enabling clients to leverage their high-value investments in these critical core systems and integrating them well with hybrid cloud can be a key advantage. However, there are some challenges to achieving a successful integration. One of the challenges we've seen is really in the limited degree of cloud integration that may be possible with existing applications. In many cases, the applications have not been modernized or transformed in several years or even over a decade. So the ability to integrate cloud capabilities well with core systems can be a challenge. In addition, information delays, such as stale data that is available for these new applications, can cause a significant negative impact to how quickly cloud adoption can happen for a client and the value that those applications can bring. Thirdly, there are complex information needs that we're seeing, across our client use cases. In many cases, the information really needs to come from multiple systems and blended together in order to deliver that value to the cloud applications. And then last but not least, we're seeing that in many cases, the applications are fairly tightly coupled, and the exploiter of that information needs to be aware of underlying data format and context within the systems of record in order to really make effective use of that environment. Now, I talk about information versus data, and I wanted to highlight specifically why that's of relevance when we are talking about high volume systems of record. If we look at these systems, they generate high volume as well as high value data across many different formats and many different application contexts. Also today, there exists a number of processes, tools, etc., to move raw core systems of record data to various targets. These could be warehouses, data lakes, other stores of raw data. And while the physical format of the data and access mechanisms may be changed, the content of these stores is generally still raw data, having the same context that it had on the core transactional systems. Now, there are applications that need that full scope of raw data and leverage one or more of these data stores. For example, existing reporting apps that may be written to specific warehouse technology interfaces. Over the last few years, there have emerged data virtualization technologies that enable access of that raw data in place, and some of these applications can leverage virtualization functions. What we're seeing is clients increasingly evaluate clouds of choice as part of their transformation strategies. Using today's technology, they can implement these cloud-native apps that use one or more full copies of the raw data that exist in their environment, or move raw data to cloud environments, or use virtualization to access the raw data, or invoke specific APIs to the core systems to get the data. Now, even with these capabilities and technical possibilities in terms of how the raw data can be accessed, we're hearing from clients that there's still an unmet need. There's a need to have faster cloud development of applications. There's a need to have more agility in how quickly these applications can be deployed, and a decoupling from the underlying core context of the data that exists on core systems. And further, there's a need to blend information from multiple systems. So for example, if there are 9 raw data elements that are computed upon using specific logic to produce the relevant account status or balance, this dependency and the calculation of that and the logic to determine how those data elements are put together has to be embedded in the logic and code of multiple cloud native applications that need that information. And so we're hearing that there's a need to leverage more event-driven approaches where the events consumed by cloud apps are not matched one for one with every transaction from core, but rather an aggregation and mediation of a set of events to determine if and when a cloud app should take action. Now, the Digital Integration Hub is an industry concept that can help to address these needs when it's well integrated with the systems of record. It's the representation of information that is derived from one or more data sources. Now, technology-wise, the Digital Integration Hub consists of a computation engine, an efficient in-memory store for that information, along with a mechanism for integration with core systems of interest. It also enables the consuming cloud-native app to decouple, not just from the specific format of the data, but from the underlying logic of how the specific information needs to be composed. Governance and auditing of information is key, and being able to have separately managed instances of information used in a many-to-many approach by cloud apps also decreases the overall risk posture for the organization. Now, the Z Digital Integration Hub is an IBM offering that delivers the ability to create context-specific in-memory instances of information where that information can be derived from one or more sources of systems of record data. It exemplifies the industry concept of Digital Integration Hub. The optimized in-memory instances and compute are Java-based. They're built upon, in this case, GridGain Enterprise for ZOS, which is the enterprise version of Apache Ignite for the mainframe environment. The GridGain Ignite instances integrate via fast local sockets with the IBM Data Virtualization Manager for ZOS, called DVM for short. And on ZOS, fast local sockets provides memory-to-memory communication and optimizes that IP protocol under the layers. The DVM capability then provides a highly parallel and optimized access to a wide array of data sources on IBM Z as well as off-platform. And in addition, for some use cases relative to environments like DB2 or IMS, there's ability to read the underlying data sets directly and further minimize impact to any core transactional systems. Now, the instances of the Z Digital Integration Hub, of course, can also be clustered for throughput, scale, and HA. And one of the key areas that we want to focus on is how the content of the information in the integration hub can be kept current as the systems of record data is changed with these transactions and batch operations that are ongoing. And there's 3 fundamental ways how that happens. One is we could certainly drive the logic that's in the integration hub and populating the integration hub at short intervals to pull that data and drive that compute and repopulate and update these instances. Secondly, we can use techniques that you'll hear about from Sean coming up, where the data can be written to a ZOS facility called Logstream that then can be consumed in a stream-like manner by the integration hub to drive the update capabilities to keep this information current. And thirdly, I'll talk about in a few minutes a future capability that we have coming up to drive change data capture tools to automatically keep this information refreshed when there are changes detected to the underlying data. Now, of course, cloud-based components can leverage the instances of the Z Digital Integration Hub via a variety of interfaces, including REST, JDBC, or event-based flows with Kafka. It doesn't eliminate the need for interaction between cloud components and transaction managers to drive updates, but for inquiry-driven processing, which is a significant portion of the interaction between cloud components and systems of record, the Z Digital Integration Hub can provide a significant advantage through fast, efficient integration with core systems data, combined with in-memory processing of that data to create the information, and sharing of that information via standards-based interfaces. Now let's look at a few use cases for the Z Digital Integration Hub. Almost every client we speak with is pursuing core modernization of some kind, and the range of strategies varies widely. In many cases, although the technology capability of the underlying Z platform have continued to evolve significantly and offer a rich set of options, the applications themselves have not been modified in, as I mentioned, several years or even over a decade. This can lead to point-to-point interactions and data contexts that are embedded in the logic and unavailable for metadata functions. And of course, this delays insight. Now, specifically in the financial services arena, the vast majority of our clients are looking at progressive modernization approaches, where there are incremental enhancements to core systems and assessment of which capabilities may be able to leverage cloud efficiently. There's a variety of paths that clients are taking for modernization, and these are not mutually exclusive by client or even by application. One key approach to modernizing is a focus on creating an agile and flexible flow of information with the Z Digital Integration Hub. Now, in some cases, there's an often fairly lengthy time of coexistence between capabilities that are cloud native and existing core functionality. And as clients modernize their existing core apps, the related data formats and contexts will be in place during that period of time. So even as select components may be deployed in clouds of choice, there's still a need to exchange information with core systems. And that's where the Z Digital Integration Hub can provide an optimized interaction capability. It can provide a shorter term return on investment, since the approach doesn't require that the application and data have to be rewritten prior to delivering business benefit. Now, another use case is the ability to integrate the Z Digital Integration Hub with a multi-cloud cache. We know that our clients, almost all of our clients, are exploiting cloud for various capabilities. So with the Z Digital Integration Hub that's integrated efficiently and well with systems of record data, individual information variants or instances can be populated with the right information that needs to be surfaced. And then that can be shared through standards-based interfaces with another layer, if you will, of a cloud-based cache or a cloud-based data hub that could bring in a combined approach of the information that flows from Z systems of record with information that may be coming from other platforms as well and other environments. And so the Digital Integration Hub deployed on Z in this example really provides that level of mediation so that not all of the raw data has to flow to cloud environments, which can be a particular challenge depending on the volume and latency requirements that are in place. Now, we know that many of our enterprise clients are expanding their ecosystems and they're choosing to partner with a variety of ISVs that are focused on industry examples. Now, in this example, we look at a particular ecosystem partner, Zafin, whom we have worked with to provide added value in the area of rates, fees, and pricing for banking clients. Now, typically, ecosystem partners like Zafin integrate with core systems, often via linkage to ETL processes and tool chains, relying on data that's been extracted at some interval. This, of course, leads to the use of stale data feeding the ecosystem functions, in this case, feeding rates, pricing, and rewards. With the work that we've done in collaboration with the Zafin team, we integrate core systems through the Z Digital Integration Hub, enabling a fast, real-time view of the core banking system information, as well as the ability to serve that information via standards-based APIs. In fact, we'll have a deep dive on this topic jointly with the Zafin team, as well as a demo coming up at noon today at the IMCS. Now, from a futures perspective, IBM is working collaboratively with both GridGain as well as Rocket Software, another business partner, to capture and process changes to the underlying data more efficiently. We've seen clients struggle with implementations where they've tried to move all of the raw data off the platform, or all of the changes are attempted to be propagated, particularly when there are high transaction volumes in play. Now, this approach leverages the Z Digital Integration Hub foundation that I just spoke about, but then builds on that. So we leverage the DBM capability to initiate and set up replication sessions with the relevant CDC software. And in this case, this is the IBM set of CDC suite of tools. Now, the replication session can really be set up based on an identification of what data and what tables really need to be monitored for change, because of course you want to be selective about that decision. Once the replication session, of course, is set up, we can then leverage the change capture processes through the CDC tools so that the data in the underlying environment as it changes would be propagated to the Digital Integration Hub environment and to the GridGain environment. However, one of the key use cases that we have from clients is not just to change data capture and capture all of the data to populate an in-memory environment, but to really use that changed data to redrive the compute logic that is the force behind what information is in the caches. So, for example, if data X, Y, and Z change across a variety of these data sources, that may trigger a recomputation of one or more of the caches that are present in our GridGain part of the Z Digital Integration Hub. So that recompute is really important. Rather than just taking in all changes and propagating them, it drives the recompute logic, determines what needs to be updated, and keeps this environment current for, of course, interaction outbound with the same kinds of interfaces that we talked about before: REST, JDBC, Kafka, etc. So an effective digital integration hub that efficiently interacts with core systems of record delivers value to our clients. That delivers value in how quickly they can leverage and operationalize their new capabilities that are often deployed in hybrid cloud environments. In addition, this integration hub can provide clients with an agile way to expand their ecosystem of partners more quickly and achieve a faster time to value from that integration. And last but not least, leveraging a Z Digital Integration Hub enables our enterprise clients to leverage their investments in core systems and transform in a way that is non-disruptive. So now I'll hand it over to Sean from M&T Bank to talk about the value that he sees for the Z Digital Integration Hub in his organization.
Thanks, Mythili. I appreciate that. Great to be here. I just wanted to start off by quickly giving a brief background into who we are. I won't go into every bullet here, but just a few. So M&T is a large regional bank based out of Buffalo, New York. And based on the map there on the right-hand side of the screen, you can get an idea of our footprint. M&T is one of the top 20 largest independent commercial banks within the U.S. with 140 billion in assets, 98 billion in loans and leases, and 115 billion in deposits. Okay, now let's jump to the next slide here, where we'll get into some more technical stuff. I just wanted to give a little insight on what specific technologies we're using from a ZOS perspective. I know a lot of you out there probably are not too familiar with ZOS, so I just want to set some context. Now, as far as our data goes, the majority of our applications don't use a traditional RDBMS, although we do have a small DB2 footprint. But in general, they use something called vSAM, and you can think vSAM as a very basic key value data store. It uses a B+ tree similar to many other products out there. Again, very basic, but also very fast and efficient. Now, as far as our application runtimes go, we use a middleware called CICS Transaction Server, or sometimes referred to as KICS. You can think of this as both a web server and an application server. KICS gives you the ability to run many instances, which we call regions, which allows you to configure, say, one region as a web server, which handles all your HTTP traffic, and another region or set of regions as application server, where you can run your application code. So now on to data access, and you can kind of see the picture on the side of the screen there. For real-time access, the majority of our applications use REST and MQ, although there are a few stragglers out there that still do use a straight-up TCP/IP, although those are in the vast minority. Over the past 5 years, we've seen a dramatic shift to REST, and we're assuming that that'll continue to grow. So now for non-real-time data access, FTP is heavily used by almost all of our applications. So into some challenges that we're facing today, some pain points that we have. Currently, we have no way of streaming data or emitting events. Secondly, as I alluded to before, FTP is really the only method of transmitting large amounts of data. So typically what we see is applications will run a post end of day batch extract of their vSAM data, then FTP that data off platform to an FTP server, where generally distributed applications will come and pick up the data, transform and load it into their database or something along those lines. This is obviously an inefficient process. Lastly here, our raw data, our vSAM raw data is not intelligible. And really what I mean by that is, for example, say you have a business analyst or a tester that simply wants to look at the data. Maybe they're working on a project where they have to build a test bed with specific criteria. In today's world, they'd have to pick up the phone, send an email to someone who would have to write a report and then email them back, the next day or 2 days later, right? So again, not a very efficient process. Okay, so moving forward, our solution objectives. What we're looking for in a solution here, I kind of broke it down into 3 separate objectives. First being event-centric. One of our key objectives was to enable our z/OS apps to become more event-driven using modern technology, i.e. Kafka. Also, we wanted to be as least disruptive as possible to our current transaction processing environment, which I alluded to before as KICS. We really didn't want a solution in which we would have to be rewriting core modules within each of our applications. More so, we were looking for a solution that would allow us to augment or extend our current application stack. Okay, secondly, data delivery and presentation. Like many large organizations, we have a vast IT ecosystem comprised of many different technologies. For us, it was critical to be able to support all those frameworks. So whether you're a Java app running on Linux and you want to use JDBC, or you're a C# application running on .NET and you want to use ODBC, or say you're a data scientist and want to use something like Python, or again, even a tester or end user and you just want to use a SQL client. So we want to be able to support all those. Now on to performant and cost effective. So we were looking for a performant and cost effective solution, which, I guess that's pretty much goes without saying. Everybody would look for that. But I think what was unique is we were looking for a solution that would completely run on z/OS, so that the both data and compute could be co-located, which we felt would ensure the lowest latency and best performance. we were also looking for something that was highly zip or specialty processor eligible. A zip is an offering from IBM in which you can think of it's a specialty core, which allows generally for better performance as well as a steep reduction in cost. So to sum it up, we're really looking for a drastic paradigm shift in the way that we're managing our data access on ZOS. Okay, moving forward to the next slide here. So choosing a solution. So the reason we decided to go with the Z Digital Integration Hub is we really felt that it met and in some cases exceeded what our objectives were. As I was mentioning in the previous slide, as far as performance and cost efficiency, it runs 100% on ZOS. It's over 99%, I believe, eligible to run on those specialty cores or zips. Which is obviously allowing for greater cost efficiency and performance. I also want to mention that this solution highly leverages parallelism, which is really a huge benefit as well. So now, as Mythili explained earlier, the Digital Integration Hub is comprised of two separate components, which really allow for a flexible design pattern. I'll just briefly go through a couple specifics on what we like from each of these products. Probably not going to do them full justice, but I just want to point out some highlights. So first, the first component, DVM, or the Data Virtualization Manager from IBM, allows us to virtualize any data asset on ZOS, whether that's vSAM or DB2 or sequential, or whether that's Logstream, which I will talk about a little bit later. It supports both JDBC and ODBC, and it's ANSI SQL compliant. And although I didn't call this out specifically in what we were looking for, it's a key feature. So next, grid gain for ZOS. I know many of you out there are already familiar with the benefits of this product, so I won't go into too much detail, but we really feel that grid gain is unique in that it's not just an in-memory key value store, it's also an extremely powerful in-memory compute platform as well. It offers native persistence, right? Not all data needs to be in memory. It's got a feature-rich runtime which supports many different languages, APIs, and access methods. And then lastly, it's also ANSI SQL compliant with secondary index support, which again, we feel is a key benefit. So moving on here, our use case. So now that we've kind of picked a solution, we needed to figure out what the best path forward was. So after many internal discussions between ourselves, IBM, Rocket, and GridGain, we decided to enter into a joint collaborative pilot using IBM's Performance Lab. We felt that this would really be the quickest way to kick the tires, prove out our use case. As many of you out there know that sometimes it can be challenging to run a POC or a pilot in-house, especially with newer technologies. Anyway, so for our use case, we had a handful of scenarios in mind. We wanted to choose something that was simple enough that we could complete within the time frame that we had, but we also were looking for something that would allow us to fully exploit the performance benefits as well as become a more generalized design pattern moving forward. So we picked a scenario in which our core deposit system needed to pass data to a payments decisioning application. So we have a core deposit system that's running on Z, and then we have a payments decisioning application that's running on x86. That's a Java application. So this payments decisioning application actually also works very closely with an external third party business partner and has a very tight SLA windows. So I'll just talk a little bit about what today's state is. There's basically two processes that occur, and these are batch-driven processes. So the first process is what we call bulk load, in which the core deposit system creates an after batch extract. Basically, it just reads sequentially through all of our VSAM files and drops the extracted data onto an FTP server. The payment decisioning app then picks up the extracted data, transforms, and loads it into their database for fast access. Now, the second process here, in an attempt, I guess, to keep the data in sync, the core deposit application creates periodic deltas of changes that have occurred. Same type of process. The delta is then again dropped to an FTP server, where the payments decisioning app again picks it up, transforms it, and updates their database. So you can kind of see that this is not only an inefficient process, but also there is a large gap where the two apps are out of sync. So moving on to our desired state here. So we've injected the Digital Integration Hub into the architecture, and similar to before, we still have two processes, or in this case, let's just call them Java apps because that's what they are. The first app, again, following the previous processes, is a bulk load. It runs post end of day batch, and what this app does now is it queries the core deposits VSAM data via DVM. It then builds and updates multiple Ignite caches based on the VSAM files. And on the next slide, I'll have a couple interesting performance stats. So now at this point, what we have is a fully functional set of Ignite caches representing our core deposits data. I guess now before I jump into what the second Java app does, which keeps the data in sync, I just want to point out that in this scenario, the core deposits app is leveraging the ZOS logger for change data capture. Mythili alluded to this earlier. The ZOS logger is a low-level, high-speed, immutable logging facility for ZOS. It's available for use by any application. I guess the typical exploiters you would see are IBM middleware products like Kix, like MQ, as well as multiple vendor products. So anyway, so onto the second app that will keep the data in sync. So this is actually an application that is continuously running in the background, and it simply pulls the logger records, or the ZOS logger records, log stream, which have been written out to the logger by the core deposit app, and updates or inserts records based on that into the Ignite caches, which were previously created. Lastly, the changes to the Ignite caches are also written out to a Kafka topic via the Kafka source connector from GridGain. So to sum it up, what we've accomplished here, we've created caches that are completely in sync with the core deposits data, as well as streamed changes to that data to a Kafka topic. This approach enables the payments decisioning app to get rid of their self-managed database. We also believe that this is a pattern that other applications within the ecosystem will follow. So a couple key advantages I wanted to point out here. Firstly here we have our payments decisioning application, right? And now this is in our current approach, what currently happens today. Now we can see that our daily load process, and this, what this includes is the extracting of the data off the raw VSAM files, and this also includes actually FTPing, or dropping that data onto an FTP server. Now, so this takes 45 minutes. What this doesn't include is the time that it takes for the payments decisioning application to actually pick that data up off the FTP server, process that data, and load the data in to their database. So now we can see here that with using Digital Integration Hub, we have now dropped that daily load time down to 4 minutes, right? So we've got over 11x performance improvements there. And I guess I also want to mention that this doesn't include the time that it takes, this doesn't include the time that it takes for that app to load the data, that payments decisioning app, which can now take the data as is and doesn't have to transform the data into their own database. So I just got a couple more bullets here. They're not specifically related to our use case, but I felt they were kind of relevant. So like I was alluding to before, we do use a lot of REST APIs that go directly to the source systems on ZOS. And we found that on average, comparing the same data when accessing it through a REST API, we're typically coming in at about 94 milliseconds. Now, querying that same data from a SQL client in the Ignite cache generally is about 3 times faster. So we're seeing on average about 31 milliseconds in elapsed time there. Lastly here, and this kind of goes back to what I was talking about with, you know, if you have a business analyst, a tester, an end user, somebody like that who needs a report. So not only will they be able to run that on their own, but we can also see here that the time it takes, we ran through some data, about 4.3 million records, and using our standard batch reporting tools, that took just under 4 minutes. Querying that data with the IBM Data Virtualization Manager, the same amount of data, 4.3 million records, took about 41 seconds. So we can see over a 5x improvement there. I guess also this was done without really any performance tuning. Which we feel like once we get all the knobs turned and everything tuned correctly, that we'll be able to run these queries even faster. Okay, I'm sorry, that wasn't last. Price performance is last. So what we can see here, our price performance, we have minimal use of the specialty cores on the left-hand side with our current approach. And again, with DIH, we see over a 99% use of specialty cores. Again, this allows for better performance and is also much cheaper to run. So, So moving forward, M&T Bank architecture based on a Z Digital Integration Hub. So I just wanted to kind of point out and give an overall picture of what we feel like our architecture will look like with the Digital Integration Hub. So you can see over here on the right-hand side, we now have the ability, our data is now intelligible. So we can access via SQL client. You can have a user access and be able to understand that data. Below that, we have all of our, like I mentioned before, or not all, but some of the access methods, APIs, and languages that are now supported. So we really feel like we'll be able to support all the different frameworks within our ecosystem. Now, lastly, on here we have Kafka. So we feel that this solution really allows us to emit events and stream data, creating a real-time and current information flow. And that's That's about it. That's about it. That's about all I have. I appreciate being able to speak here today, and thank you very much.